Alright guys, so there's a couple questions here, and feel free, I'm always happy and excited to answer your questions, okay? Alright, it says number 7 on page, I think was it 504? I think so. So this is page 504. Number 7, okay? And it says create a graph of E versus F for iron and zinc. So it says use the values from table 1. So we go down here on table 1, it's in your textbook. We find iron has a work function of 4.67 eV. Okay, and we also find, pardon me just while I check something. Yeah, okay. I guess we'll convert that to joules. We'll convert it to joules. Okay, and what was the other one? Zinc? Okay, iron and zinc. Okay, so zinc is down here somewhere. Zinc has a work function of 3.63, so we need those two numbers. All right, now what we're going to do first is find the threshold frequency. So the threshold frequency for iron, okay, will equal the work function divided by h, which is Planck's constant. Now we're going to have to convert the work function into joules, so that's going to equal, for iron, it's 4.67 eV, so it's 4.67 times 1.602 times 10 to the negative 19 joules per electron volt. Okay, and we're going to divide that by, this is to convert, right, from EV, whoops, I didn't do that right, from electron volts into joules. That's a conversion factor. And divided by Planck's constant. And let's see what we get. Okay, so I'm going to get 4.67 times 1.602 exponent 19 negative equals divided by 6.63 exponent 34 negative. And I get 1.128 times 10 to the 15 hertz. Okay, so that's the threshold frequency for iron. That one is for iron. Okay, now let's do it for zinc. Again, F0 will equal W over H. Now the work function is different for zinc. It is 3.63. All right, so this is going to equal 3.63 times 1.602 times 10 to the negative 19, like this, divided by 6.63 times 10 to the negative 34. And what do I get? 3.63 times 1.602 exponent 19 negative divided by 6.63 exponent 34 negative equals, I get 8.77 times 10 to the 14 hertz. Okay, now we're going to draw our graph. It's just going to be a sketch. So when you're sketching this, you need to make sure you have some negative value space. Okay, so the work function for, here, we're going to go energy versus frequency. Okay, and this is energy of the photoelectrons versus frequency, okay, of the emitted photoelectrons. What you're going to find is iron starts at 4.67, but we would convert, let's just leave it in electron volts. Let's leave our energies in electron volts. We'll put our frequency in hertz, and we'll leave this in electron volts, okay? Just for fun, because we can choose whatever scale we want on our axis. It makes it easier to graph the work function. All right, so iron will start, I'm going to use red for iron, because when it rusts, it's kind of red. So that would be negative 4.67 down there, okay, for iron. And then what's going to happen is the graph is just going to go like that, and this value here would correspond to 1.128 times 10 to the 15 hertz. 1.128 times 10 to the 15 hertz. The slope will equal Planck's constant, okay? Now, let's do the same thing for zinc. I'm going to use blue for zinc. So zinc, it's 3.63, so we would go down here. It's just a sketch. Negative 3. Here, let me zoom in so I can make it a little nicer. So negative 3.63 down here. And then that is going to have the same exact slope. Okay, different x and y intercepts, but the same slope. So here, that frequency would be 8.77 times 10 to the 14. And that, my friends, is how you answer number 7. Create a graph of E versus F. And it says use the photoelectric equation to determine the threshold frequency of each metal. So done and done, we determine the threshold frequency. Okay, and we drew our graph. And again, they're parallel lines. They're always parallel lines. The slope will equal h in this case. And that's it. Okay, so now let's go ahead and do number 15 from the same page. Okay, it says light of a frequency illuminates a blah blah blah. Its work function is what is the maximum speed? Okay, so photoelectric equation EK equals HF minus W minus Q times the voltage. Q is always the charge on the electron, and V is always the voltage, right? In volts. So, you know, everything's going to be converted to joules, so it's going to be 6.63 times 10 to the negative 34. So that's fine. Then you multiply it by 8 times 10 to the 14. That's F right there. Okay. This is W, but W we're going to have to convert to joules by multiplying by the charge on the electron. Okay. So that's W there, but then we have to multiply it to convert it to joules. And then we're going to minus 1.602 times 10 to the negative 19. That's the charge on the electron Q times 1. Okay, and that, it says what is the maximum speed. So you're going to write to get the speed. Well, first, let's figure out how many joules this is. Okay, so plugging all that into your calculator, lots of really tiny numbers, right? And then the frequency is quite large, 8 exponent 14 minus 1.2 times 1.602 exponent 19 negative minus 1.602 exponent 19 negative. I get 1.7796, I won't round it, 7796 times 10 to the negative 19 joules. Okay, and then just, that's going to equal 1/2 mv squared. Okay, that's what the kinetic energy equals, right? 1.7796 to 10 to the negative 19. So solve that for speed. The mass of the electron is 9.11 times 10 to the negative 31. They don't tell you in the question, but it's a known value, so you can just either look it up or, you know, whatever. There's a, you know, a table at the back of the textbook you could use, but that number would be given on the test, of course. Okay, so now just solve it for speed. So I've got this really tiny number there. I'm going to divide it by 9.11 exponent 31 negative, times it by 2, and take the square root. And I get 6.25 times 10 to the 5 meters per second. Those guys are really whipping around in there. Okay, so that is the speed of the electron, and that is how you do number 15. It's a typical photoelectric question. Okay. Next question. Calculate the magnitude and momentum of a photon with a certain amount of energy. Okay, so we know that momentum is h over lambda. Okay, that was de Broglie's equation, right? So it's h over lambda, but we don't know the wavelength here. So what we're going to do is we're going to get the wavelength, we're going to go hc over, hc over lambda has to equal energy, right, in the photon. Okay, so therefore lambda will equal hc divided by the energy. Okay, we're just going to cross multiply here. Okay, and then we'll just plug in these numbers. The energy is equal to 150. That's this number here. That is your energy, right? So that energy equals 150, but we must convert to joules. times 10 to the negative 19. Okay, it's 150 EV, so we have to convert that to joules. So let's do that first. 150 times 1.602 exponent 19 negative equals, okay, and I get 2.403 times 10 to the negative 17 joules. Okay, so now I plug these numbers in. Store that one in memory, and I go 6.63 exponent 34 negative times the speed of light, that's 3 exponent 8, and then divided by our energy, and I get 8.28 times 10 to the negative 9 meters. That is in the X-ray range. Okay, so lots of energy in that photon. All right, so there you have it. That's those 3 questions. I think that's all that was asked so far. But guys, I just want to show you, like, I mean, a lot of these are just one step, one equation. And they're weird questions, ones that, like, unlike anything we've seen, before. But, it's an open book thing, so you can, like, have notes, summarize, the questions on next week's test. These will be, well, the first one's not multiple choice, but, like, maybe the second one I would do as a written question too, but this third one would be a multiple choice question. All right, then, so that's it, and I hope you enjoy your afternoon.